Good afternoon. This is Charlie Berger. I'm the Senior Director of Product Management at Oracle for the data mining and advanced analytics features of the database. And in this session, I will be covering the Oracle Advanced Analytics option, which is comprised of both the Oracle Data Mining component and the Oracle R Enterprise component of the database. And I'll primarily in this session be covering the Oracle Data Mining offering and its integration with SQL Developer. I'll be talking about big data analytics and how the Oracle Advanced Analytics option supports big data analytics, again through the two components of that option, Oracle Data Mining, which provides SQL and PL/SQL focused in-database data mining and predictive analytics, and also I'll touch upon Oracle R Enterprise, which integrates the open source R statistical and programming language with the Oracle database. Focusing on data mining and predictive analytics, for those of you who are new to this, I want to discuss that briefly for the overview and value. And predictive analytics enables you to develop mathematical models to help you better understand the variables that drive success. And predictive analytics is based on finding formulas that compare past successes and failures based on patterns and relationships that are found within the database. And you can use those patterns and relationships that are discovered through Oracle Data Mining to make predictions about the future or to give greater insight to running your business. And the value of predictive analytics is obvious. The more you understand your customer behavior and their motivations, the more effective your marketing will be towards them. Now, predictive analytics is also applicable in healthcare, in insurance, in federal government and public sectors. There's a variety of different use cases for predictive analytics. It tends to be something that people talk about with respect to customer behavior most often. And there are a couple of books that are great reading out there for you that are wanting to read up a little bit more on this. The Competing on Analytics book written by Tom Davenport and Jeannie Harris is a great one. You can also just Google for the Harvard Business Review original article on that. And that's about an 11 or 12 page document that really summarizes the topic. And it really talks about how some companies have built their very businesses on their ability to collect, analyze, and act on data. And it goes through a number of different examples. The Super Crunchers book is also a great read, and I highly recommend both of these books. Now, for those of you who are new to data mining, I always like to show this slide. It's inspired from a book written by Michael Berry and Gordon Linoff called Data Mining Techniques for Marketing, Sales, and Customer Relationship Management. I highly recommend it. And what I want to show is if you try to find the patterns about your customers, in this case cell phone customers versus loyal customers, the ones in blue, and you have just two dimensions, two attributes, income as it goes up on the y-axis and customer months as it extends out on the x-axis. And I try to fit a straight line fit through that data as we've all done in high school and in college. It shows that it doesn't really make a very good fit. It's just way too simplistic. There's a much more complex pattern going on here. And if I tried to add some curvature to that, so with more of a quadratic or polynomial type of fit, I could do a better job, but it still is, it's picked up a few more of the blue ones over on this side, and it's picked up this red one over here and added it to these guys, so it does a better job. But a machine learning decision data mining technique called a decision tree would just carve right through that very quickly and find those patterns. And the nice thing about a decision tree, and of course we have that in the Oracle Data Mining product built natively inside the database, the nice thing about a decision tree is that a byproduct of a decision tree are these English-like readable rules that says if customer months is greater than 14 and income is less than $90,000, then I have a prediction. I predict that this person is going to be a cell phone churner based on past cell phone churners that I've looked at. I'm studying this data. I find this segment, I find this population, so I can now make a prediction with 100% confidence because 8 out of 8 of the people that fit this profile in fact churned. And the support talks to what percentage is this segment of the population compared to the larger population. If I look up here, I have another market segment that I've discovered, and it also has people who are likely to churn, but here in this case I'm only 83% confident. So that gives a nice sort of high-level depiction of data mining and how it provides insight and, if the models are reasonable and useful, actual prediction about what might be happening in the future. Now back to the Competing on Analytics book by Tom Davenport and Jeannie Harris for the book. They give a number of different examples about supply chain how to look for inventory stockouts and connections with different factors that run the business. The most common ones are usually in the customer selection, loyalty, and service, also product quality, warranty analysis, quality control sort of impacts, human capital management, really trying to predict which employees are likely to perform best in different situations, and it goes on. So I won't try to summarize the whole book or the articles here, but I do recommend them. And the key about big data analytics going forward is really articulated well here by an industry analyst, Jim Kabilius. The bigger you get, the more likely you are to be doing extensive data mining, and the more likely you are to be implementing or moving towards in-database analytics. The issue is that traditionally most people have taken their data out of the Oracle or IBM or various different databases and brought it out to a separate analytical sandbox, some statistical analysis package where they perform their analysis there. And as you get more and more data and you evolve into really what people are calling big data, at a certain point that amount of data that you have becomes sort of immovable. It becomes less and less practical to pull that data out of the database just to do some analysis on it. So at Oracle, starting quite a few years ago, we made the strategic decision to not move the data, but instead move the algorithms. So we've essentially over time have been teaching the database how to do very state-of-the-art advanced math. So we can do clustering techniques, decision tree techniques, market basket analysis, fraud or anomaly detection. We've taught the database how to do all of these different types of techniques. And so today we have a product offering. It's an option to the database called the Advanced Analytics option. It turns the database into a comprehensive advanced analytics platform, something where you can take the data, leave it sort of in place, analyze it, and then take those results and those findings and those insights and those predictions and serve it up to others. So the complete Oracle Advanced Analytics offering is comprised of, on the right-hand side, Oracle Data Mining, which has automated knowledge discovery inside the database, 12 high-performance in-database data mining algorithms, text mining. It's all based on SQL APIs, and we'll get to it in a minute, the SQL developer GUI called Oracle Data Miner, and that component of the Advanced Analytics option focuses primarily on data mining, predictive analytics, text mining, that sort of end of things. That's all high-performance SQL focused. On the left-hand side, we have a new feature, a new component of the database called Oracle R Enterprise, which takes the very, very popular open-source statistical programming language called R, and it integrates that with the database for greater scalability and performance. And in Oracle R, you don't need to move the data either in most of the cases. You still can. You can pull the data out and run it in R, but the challenge with R has been that it's been memory constrained and a single-threaded process. What Oracle R does is it takes the power and flexibility of R and it integrates with that integrates that with the database, and where possible does function push down to pure native SQL. So Oracle R Enterprise can actually front end the Oracle data mining APIs if your language of choice is R, or there's a whole slew of additional statistical techniques that we've built into the database that we also support with Oracle R. And of course, you can always run your own favorite R package, and Oracle R Enterprise will support that. So a little bit more on R towards the end. This session is going to focus primarily on the big data, deep analytics aspect with Oracle data mining. So you've seen more about big data and deep analytics, and depending on your industry, there's a lot of different use cases. If you're in financial services, you may be trying to do credit risk analysis, cross-sell, upsell. You might be trying to do fraud detection. In retail, you might be trying to do real-time shopping cart recommendations, customer profiling, market basket analysis. Similar yet slightly different use cases in media and entertainment. In telecommunications, the common one is churn prevention, but you can also do social network analysis with Oracle data mining, or network monitoring, win-back analysis, and it goes on and on. In manufacturing, public sector, transportation, and utilities, they all have popular and common use cases for data mining and predictive analytics. And so again, to summarize, with Oracle, with both the hardware and the software sort of engineered to work together, you have the data warehousing offering, and which is comprised of a number of different components, but the Oracle Advanced Analytics option is typically thought of as part of that stack. And in that, as I said, we have the Oracle Data Mining and the Oracle R Enterprise functionality, and they are really just features of the database. You don't have to go out and get something different generally. You just, if you install the Oracle database, you have Oracle Data Mining, and you have these capabilities inside the database. So Oracle has really decided to teach the database how to perform data mining, statistical analysis, advanced analytics, and so on. And if you have Exadata, in many cases we've taught those mathematical functions to perform all the way down at the hardware layer. So if you score a predictive model using Oracle Data Mining, it will actually push that predictive model down to the hardware layer, part of the Smart Scan technology on Exadata. And what that does is the value proposition is it gives you a 10 to 100 times performance improvement. If you have data mining problems and you're trying to build predictive models, typically it takes hours, days, or weeks to take the data out of the database, to do the transformations and build the models, and then bring the model that's outside the database back to the data that's in the database. It's generally has a lot of information latency going on there. And with Oracle, we just collapse that all down and do it all natively inside the database. And what that also provides, due to the sort of pricing and packaging that Oracle is offering, where it's just another feature or another option to the database, it's extremely less expensive than the other traditional statistical analysis offerings. It is generally 10 times lower cost of total ownership. And some of those other packages are rental schemes, so you never really own the software. So with Oracle, it's just another feature of the database. It's fewer moving parts and allows us to do so much more with your data while we manage it. We can also sort of think about that data. Back to data mining. What is data mining? Data mining automatically sifts through large amounts of data to find hidden patterns, discover new insights, and make predictions. And data mining can do a number of different types of things. There are different classes of algorithms, different functions that each do different things. But if you're trying to predict a customer behavior, that's typically what we call a classification problem. We're trying to classify the records into zeros and ones, or A, B's, or C's, or goods or bads. If you're trying to predict or estimate a value, like the value of a home or the lifetime value of a customer, how much business am I likely to do with this new customer that just joined my customer list and hasn't really done a lot of business with me so far, but based on the data I have, I can make a prediction based on the behavior of other customers and how they looked at that stage of my relationship with them. That predicting or estimating a value would be called regression, and it goes on. There's different techniques, each that solve different types of problems. So back to the overall value proposition. If you're going to build a predictive model using traditional analytics, generally the very first step you do is you take the data out of the database. That's traditionally what people do. They bring it over to some statistical analysis package. Then the very next thing they do is they do data transformations. Like if I'm trying to predict which employees are likely to leave or stay, maybe the bonus amount that they've received is a good predictor of that. But as I think about that, I start to think, wait a minute, if they got a high-level bonus this year and last year they got an even higher bonus, then they may still be likely to leave because the bonus amount declined. So maybe what I need to do is think about computing a derived variable that calculates the difference between the two. And with Oracle, things like that are just native SQL. They just happen natively in the database. So I don't have to do the transforms out of the database. I don't have to build the models out of the database. I can do all of that just as native pure functioning inside the database. And I'm doing that with faster time to go from raw data to insights. I'm doing a lower total cost of ownership and so on. Now, let's move on to the GUI. Oracle Data Miner, which is part of SQL Developer. And in fact, I'm going to jump over to that real quickly and show this right now. Oracle Data Miner is part of SQL Developer. So if you have SQL Developer, which I'm assuming that you do, then you have SQL Developer. We generally are looking at release 3.1 and above. And Oracle Data Miner just ships as one of these extensions to that database, or to that SQL Developer. So there's the latest release of that I'm recording this presentation demo with. And you have connections to SQL Developer over here. You also have the connections to Oracle Data Mining as well here. So you have Oracle Data Mining appearing in various different parts of the SQL Developer GUI. You see data mining right here. We have a repository, which I'll cover a little bit later on. And so you see Oracle data mining also here in the help, and there are cue card tips and online help to walk you through this. But Oracle data mining now ships with SQL Developer as a built-in extension to SQL Developer. And when we ship it out, we also ship demo data, so to make it very easy for you to get started. So I'm going to show some of my demos using the demonstration data. And if you want to build a model, you go over here and get some data from the data source node, or you go to the transform nodes and you get transforms, including sample and transform. If you want to deal with text, we have nodes and so on. So I'm going to cut back to PowerPoint for a minute here. So if we're working with tables and views, we have different nodes for doing transformations, like sampling the data, performing transformations, doing aggregations. You don't have to flatten the table. We can just have a set of point of sale data, aggregate those all up, and add to our model the average amount sold, the maximum amount sold, the whatever, maybe a 3-month moving average. I can take a lot of data, join it all together, and at the end, what I'll mine will be a star schema representation of a 360-degree view of a customer. I also have nodes for viewing the data or graphing the data. And then I have a number of different modeling nodes for doing different types of things, like building market basket analysis, or finding natural clusters in the data, or maybe trying to fit a line to some data, finding anomalies, rare events, dealing with text, and so on. And then I can also apply the model once I'm done. And I also have these dealing with text. I use Oracle Text under the hood to parse out the unstructured data into what we call tokens, or basically a bag of words that we'll throw up associated with a record or with a customer that we'll use for making predictions. And covering that just in this next slide here, I might have some customer data with comments. I go in and I build some text indexes on that, and then I have for each customer a set of words. Like I've taken these words down here. Shopping at your store is a hassle. I rarely shop there, and usually forget to bring your new loyalty card. Hence, I never really get the items on the sale price. Could you have a store manager look up my account online? So what we do is we use Oracle Text under the hood or inside the database to tokenize that and serve up a nested table of each of these different unique words and the word count. So the word store appears twice here, and the other words appear once. So we can use that as additional input to cluster and classify documents, cluster and classify people, use police reports, use emails, whatever you like. Oracle Text can parse out, I think it's 150 different data types and multiple languages, and we can just use that as additional input when we mine that data. So Oracle data mining can handle both structured and unstructured data. And in terms of algorithms, there's a wide range of algorithms depending on if you're doing classification, you'll be doing logistic regression or decision trees or naive Bayes. And what I want to show is in the actual, on the website, if you want to learn more about this, and I'll get to those algorithms in a minute, you would Google Oracle Advanced Analytics, and you'd see what the option is and how you can find all about it, and perhaps go off and buy it. If you click on that and you go to the greater detail, you come over here to the Advanced Analytics option. It talks about big data and deep analytics. It talks about the two components of that Advanced Analytics option. And if you go down here and focus on Oracle data mining, that will take you to the page for Oracle data mining, which is this one, Oracle data mining, and it gives a whole summary of things. And if you scroll down here a little bit further, then what you're going to see is the technical information, links to sample programs. Those are all pure SQL and PL/SQL programs that you can play with, practice with, and so on. And if you click on the data mining algorithms, it takes you to this next page, this page, which shows each of the different algorithms, like classification, what it does, regression, what it does. And if you click on these, like supported vector machine or multiple regression, that will take you directly into the documentation. So it's a very nice way for you just to kind of quickly dive into that. So there's a number of different techniques that we support: regression, attribute importance, anomaly detection, where we're trying to find rare events, things that are sort of outliers, clustering, where we're trying to group the data into sort of similar buckets. And each of these are supported through SQL Developer as a node, so we'll come back to that in a second. So variety of different techniques for solving a variety of different problems. You can use these algorithms either in isolation or in combination. And if you're in communications, what you might be trying to do is look at churn prediction combined with social network analysis, like who makes calls to whom, from whom, and look at friends and families, look at high-value social networks, and target promotions to these individuals for upselling and cross-selling. If you're in telecommunications, you might be looking for network traffic, trying to identify patterns for network behavior and do real-time predictions. If you're in financial services, you might be looking at integrating data from a variety of different multiple sources. Maybe you've acquired this bank and that bank, and now you have a challenge of trying to find one single view of the customer. Well, if you can bring in all those different customer touch points together and have a 360-degree view of the customer in terms of your servicing their mortgage, serving their retail banking, maybe customer service calls with the customer, some transactions they've done on the ATM machines where maybe they've bounced without any cash. And if you add that all together, well, that's just data that resides in the database, and using Oracle data mining, we can mine that. If we're looking for rare occurrences, well, that's another algorithm we'll cover in a minute called the anomaly detection algorithm. So we'll cover that in a second. If you're in insurance, you might be looking at combining transactional data and unstructured data. So you have maybe you've noticed that this particular customer has had an increasing rate of claims made and the amount of those claims, and that's just data that we're adding into the mix using the SQL windowing functions. Maybe we have some unstructured data like police reports and witness interviews, and Oracle data mining might notice, for example, that in certain cases fractured and wrist, well, they have a certain amount of meaning, but it's a lot less than broken and femur. So that's just all data that's fair game for the data mining algorithms to analyze. If you have cars that perhaps have vehicle telematics, and now you're spitting out data about where the car has been and how long it's been there and how fast it seems to be going, well, you might want to mine that data to provide perhaps individualized pricing based on their driving habits and risks. And these are all described in those books that I mentioned before. In retail, down at the bottom, you've seen perhaps the Minority Report with Tom Cruise, where he's walking through the store, and based on his identity, they flash up different advertisements that are uniquely tailored just to him. Well, that's very possible for you to do with Oracle data mining in the database. As we identify who that person is, we look up that individual, we score it real time on the fly with a predictive model that I'll show you how to do in a minute, and we would give a recommendation or a suggestion on what might be the next best likely product or what type of customer this is. Also, if you have all of these point of sale transactions, I go to the store, I purchase various different things. Well, I can identify clusters of people, like people who primarily buy, let's say, green products or recyclable products. Maybe I can find segments of what they might call country squires or new empty nesters, or I'm really mining all that data for, as we said before, getting a better understanding of my customers so I can better serve them. And the analysis, when we build the models, will be perhaps a little bit of a delay, a little bit of a batch run. It might take a few minutes, maybe even a few hours to mine that data. But once that model is built, it's available as a first-class object inside the database, and you can include that in any query at any time. If you're in high-performance operations where you're collecting a lot of data off of cars or boats or different devices, you might want to analyze all that data and look for correlations and patterns in failure modes. You might be trying to increase the likelihood or the uptime of a device. Look at the America's Cup boat on the right. You see how we actually did use Oracle data mining on that, where we had data streaming in from multiple sensors, weather, water, and so on, and we mined that data and did clustering and response modeling to optimize the performance setting of the boat in each of those different scenarios. And drilling down just a little bit more on that particular one, and you can Google go to the link at the bottom there. There's a little bit more detail about that, where they had a number of different sensors, 250 different sensors, and by collecting data was only really the beginning, and they go on to talk about how they turned to Oracle data mining to analyze the water and weather and wind conditions and how to sort of set the mast and do various different sailing adjustments to try and make the boat go just that little bit faster. And you can read the articles and see that exciting use case of Oracle data mining. So let's get on to the SQL developer part of this. That's really the real meat here. And so what SQL Developer does is it provides this workflow GUI, and I'm just going to jump right into the live version of this here next. So the next few slides that I'll show, I'll just really try to show this live instead. So Oracle Data Miner is part of SQL Developer, and we have these concepts of connections, and then within a connection you can have projects. So I am going to create a new project for the moment, and I'm going to call it, well, I'm going to cleverly call it Project 1. And in that project I can create a new workflow, and I'll just call that Workflow 1, just for fun here. Workflow 1. You can call it whatever you like in your own use, in your own scenario. And the first thing I'm going to want to do here is grab a data source. So I'll go over here to the data area, click on that, and notice what it does is it immediately pops, it looks at all the tables and views that I have available to me here, and it says, well, let's go off and look at this data. I'm going to deal with this sample data right here, insurance customer lifetime value sample, because that's what ships with the product. I can also go down here and join in other schemas. So if I want to edit the schemas and add different schemas to this, that's how I do that. And those tables are now available for me to work with. I can include some or all the variables. I'm going to include all of them, and now that's my data in the workflow. If I want to view that data, I just right mouse click on it, and I can look at the SQL that's generated for that node. I can see the data, I can see the columns associated with this, and it's a very nice just grid representation of all my data. And that's pretty much it for just looking at the data. Now the very first thing that most people do with Oracle Data Mining, and by the way, I imagine what you might be doing is trying to learn this afterwards. There are a number of different training materials that we provide. If you again Google to the main page of Oracle Data Mining and you click on this Oracle by Example Tutorials, then what that does is it takes you to this page here with these Oracle by Example tutorials. And if you're going to just get started, what you should do is you should use this first one, Setting Up Oracle Data Miner 11G Release 2. And then the other one we're going to cover is this one down here. It should probably be number 2, but it's down at the bottom. Oracle Data Miner 11G Release 2. So the very first one talks about setting up everything. And if you scroll down here, it talks about setting up SQL Developer, and then setting up a new connection, and giving it a connection details. And then in the SQL Developer GUI, you want to create a new user. You want to give it the DM user. You want to set it up with their privileges to go off and do certain things. And this is all covered here. I won't belabor this in this part of it. But once you create a new user, you create a data mining connection. And in that data mining connection, as you set this up, it's going to ask you to install the data mining repository. So as you create something here, it's going to go off and it's going to say, the database does not yet have a data miner repository. Would you like to install that repository? You're going to need the system password to do this, sys password. And then after you do this, it's going to set this up. It's going to go off. It's going to say preparing. Press start to do it. It's going to take just a little bit of time to install that schema and set it all up. And then you're done. And then once you're done, the next thing you might want to do is actually set up and start using the basic product. And again, there's a very, very nice Oracle by Example that walks you through all of this. And if you just kind of look down here and see how it sets it up, you set up Oracle Data Miner, you're going to do a connection, you're going to do a project just like I did here, give it a little bit more clever name, ABC Insurance, you're going to give it a workflow, and we're going to go off and do something. So here we have a workflow, and on and on. It's going to be very much like what I've done here. So I really encourage you to not use this recording to learn from. Go to the Oracle by Example and learn from that. There's also a 2-day Unstructured course for Oracle Data Mining that's available, and I highly recommend that as well. So let's go back to Oracle Data Mining, and specifically the SQL Developer GUI here. So we have our data. What do we do next? Well, the first thing most line of business people do is they want to explore the data. So that's what we'll do here. We're going to drop an Explore Data node onto the palette here. And notice it has a little exclamation point. It's not set up and ready to go yet. So what we need to do is we have to give it some data. So now it has some data. Now you can see the property inspector down here has Explore, it has output, it has the histogram, it's going to do 10 bins for each thing. It's going to use all the data or use a sample of the data. For just creating a graph of the data, I don't really need to graph 10 terabytes of data. I can usually do a representative sample. But if you want to graph 10 terabytes of data, you can. It doesn't make a lot of sense, but you can. So we're going to go back up here to the node, and what I tend to do is click on that click on the node itself. So here we're going to do something a little bit more interesting here. We're going to group this data by, let's say, lifetime value binned. Now let's do it by marital status. So now as we group this data by marital status, as we say run, then what that does is first it saves the workflow. The workflow is an XML type object that's stored in the schema, the Oracle Data Miner schema. So it saves that first. It takes the job, the set of transactions that we've asked, that Oracle Data Miner has asked the database to do, and it submits a job to the database. You can see that being scheduled and being peeled off the database here to run. And then even though this is a small amount of data, if it were a much larger amount of data, it wouldn't have taken very much longer. It's just doing the statistics, all the math inside the database. And so now you can see that we have, for each of these variables, we've created a nice little summary. So here's age. We can see we go from 0 years old up in the 90s, and we've grouped it by marital status here too. If I have, this is one of the business problems we're going to focus on. We're looking for people who buy insurance, and it looks like a lot of the divorced people buy in blue, a lot of the people in red single buy, and the white the married. So this is the mix, and it doesn't look as if the mix of married for people that don't buy versus people that do buy is significantly different. It looks like there's a little bit more structure going on here in cars. The people the people over here that do not have cars are primarily single people, and over here it's a whole spectrum of people. Here's credit card limits, and as you can see, you can kind of go down here and look at a number of different things: number of dependents, number of mortgages, numbers of checks written, and I have all these different variables here. I also have calculated the min, max, standard deviation, and so on. The data is also viewable in a grid form, and I can just take this, drop it into some other sort of template if I want to and spit it out. Also, these results are available if OBIEE or some other tool wants to visualize or view this data in another way. That's also quite possible. But so I have the data. I'm going to explore that data, and now I've got a pretty good feel for my data and what's going on here, let's say. And the business problem, I kind of teased it before. We're going to be looking for people who buy insurance. So we're going to use all of these other different variables to make those predictions. Now this is a very, very simple case. We're just starting out with doing some data mining here. So we're just going to stick to a nice simple classification problem. We're not going to do anything else that's very sophisticated here. We're going to connect that up to here. And notice it says, what's your target field? And I'm going to say it's buy insurance. What's your case ID? What's your unique identifier that sets everything else apart? Well, it's customer ID. And now it's automatically going to go off and build me a generalized linear model. If I want to change any settings for this, well, there's my target field, there's my unique identifier. If I want to change any of the algorithm settings, I can come in here and specify that I want to do ridge regression or generate row diagnostics and so on. And I have various different settings here. If I want to do the same thing for a decision tree, I have the various different settings for a decision tree. Same thing for naive Bayes and also for support to vector machines. And I have linear Gaussian models. Now I'm not going to try and go into all the algorithm parts of this, but just suffice to say that part of our strategy at Oracle is to make this as powerful as possible, but not as complicated as possible. We want to try and make it very straightforward for people to use and really enable more and more analysis to be formed more and more easily and in a more automated way inside the database. So what that's going to do is it's going to go off and launch a model. It's going to take just a couple of 10, 20, 30 seconds here, I think, to run. But while that's thinking, not to waste any of your time, I'm going to come back here to the PowerPoints to kind of skip ahead here a little bit. So I've shown the Oracle Data Miner GUI at its highest level. And when I build a model, this is one of the ones we're going to see in a minute. This is an Oracle Data Miner decision tree. So it shows the actual total population and then split out into ever descending, ever more homogeneous subpopulations that, as I showed before, have certain, call it business rules that clearly define who these people are that are in the green here, very likely to do something, and the other people over here are very unlikely to do something. So there's various different models that you may have depending on your business problem and the type of data mining algorithm that you've selected. If I'm doing clustering, which I'll show in a minute, I take the data maybe past churners, and I try to cluster the data. And now I have different groups of people that I might want to give labels to, like local domestic people or promotional plans. But these start out just being called cluster 1 or cluster 2. And what I'm going to do here is sort of discover what patterns and relationships Oracle data mining has found to separate these records into more homogeneous subpopulations without any target field. I haven't said I'm looking for good customers or bad customers. I'm doing what's called unsupervised learning. I'm just asking the data mining algorithms to sort of sort things into piles that are similar. If I'm doing market basket analysis, I'll show this live in a second, I'm looking at all the purchases, all the point of sale data, and I'm trying to find that, oh, if you buy product 137 and 143 and product 138, I expect you to also buy product 144 with 70% confidence. So it's sort of like you bought the spaghetti sauce, the spaghetti, the loaf of bread, and at the checkout counter they say, hey, did you forget the bottle of red wine? Because most people who buy the first 3 items also buy the bottle of wine. Now, under the hood, everything that we're doing, we're showing the GUI most of the time, but under the hood, what we're really doing is we're just calling the SQL and PL/SQL APIs. As I said early on, what we're doing is just native, high-performance SQL inside the database, and we've taught the database new data mining functions. And what I'm going to do now is cut over. We'll come back to that GUI thing in a minute. It is done, so we can come back to that. But I'm going to come over here first and show you that same query that we just saw there, where we're looking at doing a claims model. And this is all we're really going to do. We're just going to run this begin DBMS data mining create model. That's going to be the name of the model. That's the type of data mining function we're going to call. Claims is the actual view or table that we're going to mine. Now that may be the result of joining several different tables together in terms of customer previous transactions, police report, the amount of the transaction. Maybe there's a number of different pieces of data that I've pulled together, but I need to know a unique identifier that uniquely identifies each thing that I'm going to try and predict, whether that's a claim or a customer or a transaction. That policy number is going to be my unique identifier. And this claim set is really just the advanced settings. It's what I was showing before. So when I run this, it's going to take just a very short period of time to build that model. And then immediately, after that model has been created, what I have then is this claims model. And I can use that claims model in any query. So here I'm going to select all customers or all claims where some other condition holds true, and I'm going to score everyone. I've got about 20,000 records here. I'm going to score everyone. I'm going to ask where this other condition holds true. I'm going to rank them, and I'm going to say show me the top 5. Okay, makes sense? So I'm going to come up here. I'm just going to set this thing, run the whole thing. So right now it's building the model. It built the model in a fraction of a second or so. Again, I'm running on my laptop. I've got the 11G Release 2 version of the database. It's about 20-something thousand records and about, I think, 30-something attributes. So it's not a huge amount of data, but if it were a huge amount of data, it wouldn't take a whole lot longer. I have customer instances that are doing hundreds of millions of records, and it's maybe taken, small number of hours to build the model. But also, once that model has been built, the model building is the hard part. Once the model has been built, I can go off and just score or do a real-time apply to anything I want to do. That model exists, and I want to show that back over here. Here's a case where I have a different model, this claims decision tree 1.1. If I go back to SQL Developer back over, excuse me, I had this over here. If I go back to SQL Developer and look at this one, I have this class decision tree 1.1. So I've built some models. It's just like what I did before. I've applied the models. I have an output. I have this decision tree, over here, I'm sorry. I have this decision tree model that we were looking at before that shows me let's just turn this thing sideways for a minute so you can see that. So I have my decision tree of the different people, and I have the conditions that hold true, these rules, this logic for different types of use cases. And so what I'm going to do is I'm going to use that model here for a real-time score. So I'm going to say, assuming or using dual these values that are coming off, let's say off the ATM machine or off the call center. And I'm just going to say, using that as input, let's just run this. And what it's done is in a fraction of a second, it scored it, and it said this person is 96% likely to, I think in this case, buy the product that I'm trying to sell them. So if they have $8,000 in bank funds and that amount their checking account, and they're 55 years old, they're going to buy my product. But if it turns out they didn't have $7,800, they just have $78, and I want to run this again, well, again, it's scored on the fly in a fraction of a second, and notice now the probability is essentially 0. So my point in showing this to you is that Oracle data mining has sort of pushed the data mining algorithms inside the database, inside the kernel of the database. You don't have to take the data out of the database anymore to do these things. You can do this in the database. And if you're a clever Oracle developer and you're using SQL Developer, we've opened up a whole set of doors for you to go off and do more complex and more interesting things. Now when I come back to this workflow, it's the same as this one right here that I just built, but I'm going to jump to this other one because it's already done. So now I've built my classification model. I've built 4 different models. What I may want to do is I may want to compare the model results. So I have different techniques here to compare the performance of the models, how accurate they are. Looks like the decision tree is very accurate. I can look at how accurate each model is for predicting yeses and the nos. So in fact, the naive Bayes does a great job of predicting the yeses. So later on, I'm going to choose to use the naive Bayes model. I have something called lift that shows the incremental sort of comparative advantage of using the different models. Depending on how deep I go into the data population, which model turns out to be the best. And I'm going to use this to sort of take the top 20% of the models, the 20% of the customers that are most likely to do something, and I'm just going to arbitrarily choose this naive Bayes model because it does a pretty good job across the board, and that's just the one I picked. And so I'm going to build these. I'm going to take this model. I'm going to take the output of that. Notice I've turned off the output of the other guys. And now I'm going to say I'm going to build an apply node. So I have the data columns I may want to carry over. I have the apply prediction probability, and we could add more and so on. I'm going to skip over all this. The tutorials do a great job of showing you how to do all this. And then once I score that, I can view the results. So here are the results. And the nice thing to do here is I might want to sort these. I have my prediction. It's over here on the right, prediction of doing something. I might just want to sort these guys in the prediction, the likelihood of being a yes, sort them in descending order. And so now here are the people that if I'm trying to sell them something or think about what they might be doing, all of these people here are at various different levels, various different probabilities of responding based on the data that I have. And I've just left that data inside the database as a scored table, or I could do it on the fly with the ever-changing data, and it really wouldn't matter much. And the way I do this is dragging and dropping these different nodes on top of the surface here and building models. Now if I want to apply this to new data, what I've done here is I've built models on this. I've compared various different models. I wanted to show just another different model type here just so you can kind of see what this looks like. Here's a generalized linear model, and here's the coefficients for predicting a yes or a no, the standardized coefficient, and so on. And then I've chosen to pick one or multiple models, apply it to a new set of data, and then this just becomes an output table that I can hook up to OBIEE or Excel or whatever you choose to present your results. So that's sort of a quick summary of just one of the types of models that you might be doing. I also wanted to show a couple of other things here. We also have the ability to do anomaly detection. So here I have some insurance claims data, and I'm going to look at the records of past claims. I'm going to build, notice they're very rare. This fraud is just what one human says. What I'm really looking for, what are the things that are absolutely the most unusual things, because I may need to send an investigator out there to see that. So in the same way, I'm going to take this anomaly detection node, I'm going to apply that to the data. It's going to give me a scored list of people. This graphical way of showing this is exactly what I did when I showed the API earlier, when I did this SQL worksheet use case before. That was doing what I'm showing right here, this scenario. And if I really like this, and I want to save this, and I want to give that to somebody else, I think this is claims anomaly detection one here, claims anomaly detection. If I really like that, I can just export that workflow and give it to somebody else, and off they go with it. I can also do market basket analysis. So here I found different items that co-occur, things that go together, and now I can say, well, maybe I'm just trying to take what if they buy this diskette, what are the things that would go with it? So here's the consequences over here. If they buy this diskette, they're likely to buy these speakers, and so on. These are all things you've heard of, probably beer and diapers. This is what we're doing here as a market basket analysis. We're really looking for if the customer transaction is identified as customer ID and a timestamp, and I'm looking for what products they've bought, and if they're in the basket, I use this a priori data mining algorithm. I just click OK. I run the model here by saying run. It does the math, and I get my association rules. And here I'm showing the combination of maybe several things together, but I'm really mining the transactional point of sale data there. So there's a number of different things we can do. We also have clustering techniques, and in the clustering techniques, I'll make this go a little bit bigger here. I have different natural clusters, natural segments of customers that pop out that are all similar. And you can see that number of ATM transactions, their bank funds, and so on. These provide the cluster rule that talk about people that are very similar together. And if I look at any one cluster, like say cluster 6, then this is the behavior, this is the lifetime value. These are the variables that most identify that particular segment or cluster, let's call it. If I want to compare some clusters, well, maybe I want to compare cluster 11 to cluster 17, and what happens is I sort these based on divergence, and I would say, well, the customers in cluster blue over here, they primarily have a larger amount of ATM transactions, whereas cluster red does not. Lifetime value, it's a little bit more dispersed, but in terms of sorting out salary, number of checks written, you can see that there are different groups or clustered behaviors, different clusters of individuals. So that's another technique that we may use in doing data mining. So I'm going to move back to PowerPoint here and move along. So you can use the APIs or you can use the GUIs. The good part about the data mining inside the database is, as I said before, if I have built this churn prediction model and I happen to have Exadata, that prediction probability function will get scored or pushed down all the way down to Exadata, so it'll perform there. And that's generally 2 to say 5 times faster, just purely doing it inside the database. And that's really an order or two orders or two of magnitude faster than doing it sort of traditional ways where you start by taking the data out of the database for your analysis. I showed this real-time prediction before and how that works. Now you can sort of integrate these predictive models into, say, a call center or an ATM or a mobile device. You've really taught the database how to think, and that's what we're doing here. If you have some third-party models and they are able to export their predictive models as PMML, Predictive Mining Markup Language, then we can import those models, and we listed a little bit of details on that. And then once we integrate those models or import them in the database, they actually become natively represented data mining models, and they inherit all the Exadata scoring, all the advantages of running a model natively inside the database for scoring purposes. Now the nice thing about Oracle data mining, another nice thing about Oracle data mining is that all the analytics, all the data, all the predictions, where are they? They're in the database. How do I get at those? Well, maybe some manager, some business user will want to access just the results. They don't have a PhD in data mining, they just want to access the results. So here I'm showing the Oracle Communications Industry Data Model that shows the predictions of which Ethan Neely is pretty likely to churn. He's a very high probability of churning here. So I see the list of customers, what they're likely to do, and this has all been done behind the scenes by someone who's used Oracle data mining. If I want to identify the factors most associated with why these individuals are leaving, I'm showing it here. I'm showing some results of clustering, and the key is a different user is using either the APIs or SQL Developer. They're leaving their results, they're leaving their findings and their predictive models inside the database for others to consume. So there's the concept of information producers and information consumers, and here I'm showing the consumers. These are other examples that I'll show sort of live here. This is with the Oracle Business Intelligence sample examples, I think is what they're called. And here I have a number of different sample applications. You can see over here I have the Oracle data mining ones right over here, a number of different things. And I've clicked on a few of these. This is my favorite one. This is a map of the United States. where I've predicted whether or not you're going to be a low, medium, high, or very high value customer, and I have the probabilities of that, and I've just counted, I've summarized those. Summarize them on there's a lot of very highly likely to be high value customers in Alaska, and you're either very high or high value. In California, you have a lot of highs. You also have a fair amount of low values and mediums and so on. So looking at the past purchases, the past behavior, the past what we call lifetime value of the customers, I can make predictions. They're all in the database. I can roll up, group by, OLAP, whatever I want to do, display them in a map, and using Oracle Business Intelligence I can do that. I can take the models which exist as objects in the database. There's an API called get model details, and I can get model details, show the attributes that have the highest correlation with my target field. Here I think whether or not they're going to be a high or medium or low value customer, and age, marital status, credit rating. These were the factors that had the highest impact. And again, using OBIEE, I can see that the customers that are have a high probability of being low value are in red, and they're mostly younger individuals, and the probability of customers being very high value are generally higher aged individuals, mostly in the 40s and the 50s. And there's a number of different ways to sort of visualize this data. You can always pick whichever visualization tool you prefer, but with Oracle data mining, the data is in the database. We present these results, and it's very easy for any other tool to summarize the results of who's likely to do what, any insights that I found. And in fact, through OBIEE, I can also do real-time predictions, sort of what-if analysis. So let's say this Allison Hurd right now is a widow, and let's say that this is her information about her credit rating, her age, and so on. And this is the prediction of her likelihood of being very high, and so on. Here's another customer here. So if I take this and I say, well, what if that changes, and I apply? So then what I have done here is just give a real-time new prediction that I can show here. I'm not showing it for the second here, but it would give the new value here of what that prediction is. And I think I just lost. I think I have to refresh here, but let's move on. So the point is the models exist as live objects inside the database that you can call and use anytime you like. So here's a few of those results here. Here's again one of my very, very favorite ones. It's an Oracle application called Oracle Fusion Human Capital Management Predictive Analytics, or Predictive Workforce, I think it may be called. And here what I've done is I've looked at all the past behavior of of employees, which employees have stayed, which employees have left, what their insurance plans have been, what their bonus amounts have been, what colleges they went to, what their reviews have been. I've looked at all this data, vacation time and so on, salary increases, something where I've had some domain expertise applied to figure out what are the right variables that should be thrown into a predictive model to make predictions. And I've said, let's just score everybody. Let's build a model, find the patterns, apply the model to all the employees. And now as a manager, I can see that Pat Miller has a large number of people who are very likely, high value, high likelihood to leave, but yet their performance is very high as well. So if I click on the data mining results of this application that factory installs predictive analytic methodologies, then I can get model details, and I can see what's the top factor that's most correlated with any one of these employees likely to leave. And I can see that, say, Julie Lee here is very likely to leave because she's been in the same position for a long time. Well, maybe it's time to give her a change. Someone else may be leaving because of the amount of vacation days they've been charged. And in the live version of this, I can right mouse click on that individual, use slider bars, change the parameters that are changeable. Let's say like the amount of vacation time she takes, or maybe give this person a promotion, let go, and it does a real-time prediction. So it's very, very cool, and it's really the idea of leveraging the analytics inside the database for making smarter applications. So we've done a number of these things, some of which are shown on this slide here. Again, if you Google Oracle Data Mining and go to the bottom of the page, it has these listed there as well, and there's links to take you off to those various different products. I want to sort of close or wrap up a little bit more with R. I talked again in the beginning about how we have the Oracle Advanced Analytics option, which is a combination of both the Oracle data mining offering, which I just went through, and then also we've recently added what we call Oracle R Enterprise, which takes the open source R statistical programming language and it integrates it with the database. So if you're not familiar with R, I'll touch upon this here just for a couple of slides. R has taken the market by storm. It's a very, very popular, free, open source statistical programming language. Okay, so it's very much like any other, I guess, very, very popular open source thing. Many students are using it. More and more companies and applications are using R because it's very powerful, very flexible, and its strength is at the bottom it's highly extensible. So any graduate student, professor, business, professional company can generate R packages that do certain specific things, and they publish them to the open source community, and everyone else can use it. So the constraints of R is that it is, as I said before, it's memory constrained, it's single threaded, and it has really sort of lacked the backing of a major corporation, a major backer such as Oracle. So what Oracle has done is we've created a new component of the database called Oracle R Enterprise. It integrates the popular open source R statistical programming language with the Oracle database for big data. So it's really designed for problems involving large amounts of data, and it integrates R with the database and enables users to run R commands on database resident data, develop and refine R scripts, and leverage the parallelism and the scalability of the database. The data analyst can run their latest R open source package and develop and operationalize R scripts without having to learn SQL, and then Oracle R Enterprise sort of looks at those R scripts. It does what's called an R to SQL transparency layer conversion of that R script into SQL, and it executes that same R intention natively inside the database because it matches up and function pushes down the R script down to native SQL. And if there are certain things that we don't 100% support in the database, let's say like a time series or a mixed model or something that we do not currently have native support for in the database, you can always run R in the embedded mode, where we really take the database and allow the database to flow the data to the R instance, which is typically installed on the same server as the database, and through remote procedure calls and external functions, we'll flow the data to the R server, run it perhaps in 10 or 20 or so parallelized, independently running R instances, and then return the results back to the user, and they can look at the results. So Oracle R Enterprise really takes the memory-constrained, single-threaded, open-source R language and makes it industrial strength. So we transparently function ship the R constructs to the database. We do the data manipulation, the select, the project, join, the basic statistical functions, all of those, and the data-heavy computations all inside the database. So if you look on the right-hand side, this example that has a simple use case of 120,000 rows looking at airline data for the departure times, the departure delays, and arrival delays, and it looks for a number of years. In a very, very small sample of the data, sure, you can run open source R, it takes 30 seconds, and Oracle R Enterprise will do that in 5 seconds. But if you bump that up to the entire set of data and say have 120 million records, well, it's really not possible with open source R. It runs out of memory, it runs out of gas. And what Oracle R Enterprise would do is just function ship that same sort of very simple calculation, leave the data in the database where it perhaps is being stored, or move it to the database and do the calculations there, and it's able to do it again in almost the exact same time. So Oracle R Enterprise has 3 different compute engines. I've sort of covered this before, so I'll do it quickly. It has the R to SQL transparency layer, the first one, step 1. It would function ship the statistical calculations down to the database compute engine, where we have an ever-expanding library of statistical functions that we run natively inside the database. And I ask you to look at the Oracle R Enterprise documentation to see the latest listing of those mathematical and statistical functions. And if for any reason we don't have native support for that, you can always use the R engine and spawn perhaps multiple R engines where the database is managing the data and the parallelism of those parallel flows to independent R threads that are doing their statistics and doing their analysis. And that really enables lights out execution of R scripts. So Oracle R Enterprise, a whole other topic here, but I just did want to pull that into the presentation here. Close by showing just a script that has a combination of several different use cases of the Oracle R engine, and so on. Again, a topic for another day, perhaps. And then summarize by saying, with the Oracle Advanced Analytics option, we combine the Oracle data mining and the Oracle R functionality. We've basically taken the database and transformed it into a comprehensive advanced analytics platform that allows you to do a number of different things. People have applications and business intelligence applications that sit on top of that data, and typically they may be used to doing, service and contact centers, marketing, procurement, and spend, and have a number of different use cases. Well, Oracle is on a strategy to automate and build out more and more predictive analytics applications, but I did want to just highlight to you, if you have the Oracle database and the Oracle Advanced Analytics option, each one of these things, like retention analysis, expense report, looking at, say, fraud, employee productivity, churn, all of these are things that it's very easy to just sort of use the Oracle Data Miner GUI through SQL Developer and or the APIs and just build an analytical methodology and just let that run as a script inside the database, or a query or a call or real time, whatever you want to do. If you want to learn more, just simply Google Oracle Data Mining. I've shown you a few of those pages already. There's also a blog, the Oracle Data Mining blog, where I have sort of more current information and updates and information about the Oracle training course that's out there. I've shown these e-training courses that are out there on OTN. I highly recommend those. And to summarize, analytics means business these days. Better analytics, better business, more profit. And I wish you all the best. Wish you all great luck. If you do have any questions, please contact me, Charlie Berger at Oracle. That's Charlie, CHARLIE, .Berger, BERGER, at oracle.com, or Google to the main websites. And I thank you for your time, and good luck.